That was not for you.
That's a different one. That's a different one. That one does not sound the same as the other one. That's Bertha. The other one's name is Frank. Okay. My chin. I don't know what to do. That's the other one. Okay. A 216 square meter rectangular pea patch is enclosed by a fence. You know what? I'm not doing this one. I like a different one that's easier. Okay. There's a river. Ready? There's a river. On the river is a pen. A pen. Or a fenced-in area, let's say. Okay? You want to maximize the area. We want to maximize the area. So that screams optimization, because optimization is where we maximum min first derivative, right? Yes. Okay. In order to maximize the area, you want to use as much of the river as, I'm seriously super awesome birds. You want to use as much of the river as you can without fencing it, correct? So you'll always make these be your widths and this be your length. So what is the perimeter of said pen? Yeah. The perimeter is 2W plus L. Now for these questions, they'll always give you how much fence you have. So the perimeter, right? They're not giving you the area. They're going to give you the perimeter. So say I give you 420 meters of fencing. Where could that go? In for the perimeter, in for P. So I get 420 meters of fence equals 2 W's plus the length, which we did this in 20-1. And then we would always isolate for one of them. I'm going to isolate for L. So I get negative 2W plus 420. And then what you guys would do is you would do max area, which is length and width, correct? And you would put in for length and width, and then you guys would have completed the square, and whatever the heck the x was like your width or your length, and the back number on your vertex was your max or your min, correct? But we're not in 20-1, we're not completing the square, we're using calculus. So if I say maximum, what does that tell you? I need to go to look for the first derivative, the critical numbers of the first derivative, correct? But I need to get area first to get its first derivative, yes? Okay, so what is area? Not max area, just the area. What's the formula for area? It equals length times width. And now I would have to go W times dL over dt plus L times dW over dt. I don't have dW over dt. I don't have dL over dt. I can't do a product rule here, right? Is there something else I could do that maybe I won't have to do product rule? Nope. What could I do?
Yeah,
substitute in for L, because I have a formula up here that has an L equals. So I'm going to get area equals negative 2W plus 420 meters times W. If I did it this way, I'd still have to do product rule. What could I do first before doing product rule?
Combine.
Yeah, combine, distribution. So we get area equals negative 2W squared plus 420W. That is just area. I want max area. When I want the maximum, what do I have to do to that equation? Take the derivative of it, find its critical numbers. So I'm going to get area equals negative 4W plus 420. And now this is an area, this is max area, because we found the first derivative. Shh. Set it equal to 0 to get my critical numbers. 4W equals 420 meters. Divide by 4, and W equals how much? 105. Because 400 divided by 4 is 100, and 20 divided by 4 is 5. So our width is 105. What is our length? How do we get that? Plug it into this one. So L equals negative 2 times 105 plus 420. So L equals negative 210 plus 420. So L equals what? 210 meters. And the width is 105 meters. So if I ask you for the dimensions, poof, you have them. But what if I ask for the maximum area? Because we haven't found it yet.
Number line. Number line, and then you take the.
Times the length times the width, and you have the area. Wow. I'm not, nope, that's you. All right. So max area is you take the length and the width and you just times them. So we get 105 meters times 210 meters.
What?
And what do we get?
22,000.
The width is 105, Ashton, and the length is 210.
Oh, yeah.
Yeah.
22050.
Meters squared. Right? So you can give me the dimensions and the maximum area. We agree? The ones we did in class where we just had like a different number and another number and we defined the maximum product or the maximum sum, right? Those are all fine too. The other ones that you guys did in 20-1 was like you were trying to sell you're trying to get the maximum revenue of canoes.
Revenue.
We're not going through the pea plant one. So maybe the pea plant one. I have no idea. It could be a pea plant, it could be this one. We didn't go through the pea plant one, and we did go through this one, so option. All right.